Okay, so we are going to start. So we're going to be making an attractor script. The idea of an attractor script is that we do not actually use the typical methods of defining variables in Grasshopper, which would be, if I want to define a variable in Grasshopper, what would you create? Anybody? Like a number. If we want to make a number, what do we make? Line. Right. If we want to write text, what do we create? Right. Can we write numbers and various other things into panels? Yeah, we can. Unless using like the Mac version, then yeah. So there are other ways to define variables. We can create variables through analysis. So, for example, I could measure a line's length as x, and then I could say, okay, make another line with the same length, right? We could the thing is, I might not define that line by its actual length, so I'm not sure what it is. I don't have a slider, so it's not like I can plug that same slider into both lines. So by measuring this line, I can then define the length of the other line. Does that make sense? Okay, so what we are going to do is create an attractor script. What that does is effectively it analyzes the distance that something is away from an object, and it then uses that distance, that proximity, to then define a variable. Okay? And for attractor scripts to work well, what you need is a monad. Is this the first time everyone has heard the word monad? Okay, good, you're all normal. Okay. So, the definition of a monad is something, it's a very simple object. It's usually got a few variables associated with it, and when it is put alongside other monads of the same type, but with differing variables, what emerges from it is greater than the sum of its parts. So from monads, we can get emergence. Everyone here looks at monads every day. And there's a super common one that uses 3 variables and is laid out in a grid. Can anyone think of something that takes 3 variables? Huh? So like circuit. Think of an object that has 3 variables, and in a system, you know, when it's in a system, when those variables change, you can get something amazing, something extremely detailed and amazing. No one? Huh? So the monad is the pixel. And when a pixel is combined in a system and it changes, then it can create whatever image we want it to create, basically. Yeah? The more pixels that we can put in, the closer we get to 4K, 8K, 16K TV, right? So all these pixels, they just have 3 variables. Those are a red brightness, a green brightness, and a blue brightness, okay? And with those brightnesses played from 0 to 100%, if they were all at 100%, this would be the brightest white this TV could produce, which I guess see that this little zone up here that says what this TV is capable of producing in terms of its brightest color. And then where it's black down the bottom is basically when they're all turned off. Okay? So this is a monadic system. Cool? Okay, so if I were to say you guys are monads, right? Your variable is just sticking your arm up in the air. Then each of you needs to then work out, well, what's determining how much I stick my arm up by, right? So in this case, there's an image and the pixels are changing their color based on the location that they are relative to the image. And for you guys as monads, I'm going to ask you to put your arm up based on the proximity that I am to you. Okay? I know some of you are looking at me like, why? Okay, it's just to demonstrate. The process that these little monads are going through, because they've got a tough life. Okay, so if I am within a meter of you, I would like you to put your arm up as full as possible. Okay, it's not a discrete situation, so there's a gradient in between. And if I'm within 4 meters of you, I want it to be low, down, and so you can extrapolate from that, further than 4 meters. Actually, let's go 2 meters, just to make it a bit obvious, because that's almost 4 meters. So let's start the system, okay? I'm a point, and you have to effectively decide how far away I am from you, okay? How far away am I?
Very close.
I'm about a meter?
Yeah.
Which means where will your arm be? Right. Now, between me and Maddie might be a meter, but it's certainly not 2 meters just beyond Maddie. So Ashley, how come your arm's not up? Right. And Joseph, do you reckon yours should be just a little bit?
Oh.
Okay, let's make it 3.
Okay.
No, so why is yours higher than Ashley's? Right? There's a gradient, yeah? And as I move around, you guys are going to have to pay attention to what I'm doing. Are you paying attention? Yeah, everyone has to pay attention. That's definitely 3 meters away, right? How come no one's paying attention? You guys are monads. Pay attention. You gotta respond to me changing, because I'm effectively defining a variable on you. And I know, yes, it's like participation. Why do we have to participate, right? But the point is, I'm demonstrating I'm demonstrating a point, okay? So, I didn't turn it off. Yeah, thanks. Okay, you can stop. Huh? Pardon?
Might need this hand to do the crossword at some point. So we might need the hand to do the...
Yeah, you might. That's why I told you to stop. Yeah.
So it's funny before you said that.
So, what we are going to do is create a monad, and in the case of what Christina initially proposed for the class, it's effectively you create a panel on your surface and you change the size of the hole in that panel based on distance to a point, and then you 3D print that. I think that's quite limiting with the outcomes, because then everyone's just going to give us the same thing, right? So we're going to talk about some of the various options that we have at the end of the class, but we are going to do this offset in class. But hopefully you guys have learnt enough to play around with more than just offsetting something on a surface. Cool? Okay, so each of these panels effectively acts as a monad, and if we imagine them in a system, we have more than one. So therefore, we've got an emergent system. There's more than one pixel, there's more than one student, there's more than one panel. Yeah? When they had one panel, it'd be a bit boring. Wouldn't really be a panel, would it? No. Okay. So, and in this case, what I'll do is I'll just draw some circles here. What we are doing is testing, and I'll draw my little attractor point as a crossed box. What we are doing is measuring the distance between each of these points to to that point. Okay? So that's pretty straightforward. We can actually write this quite simply. Like the concepts behind that are very easy. But Like, for example, it's very easy for me to say, okay, here's a list of students, here's my position, measure the distance between me and each student, and stick your arm up. You all did that fine, right? But if I then asked, well, par, you were par, it was reasonable. But if I was to say, okay, I'm also going to put Maddie in the system as also an attractor, so you have to measure the distance between me and Maddie, what do you have to do?
Think more.
Pardon?
Think more.
You have to think more. Okay, that's a great answer. It's really good. Okay, so let's say, this is my student and there's the arm position from 0 to 1, right? And we've got an attractor point here and an attractor point there. So, pseudocoding, for those of you who don't know me, I call myself two brain cell man when I go into pseudocode, because I'm going to ask you to tell me what to do in deciding what's happening here. Okay? So, if I'm going to decide where I'm going to put a point along from 0 to 1 based on the proximity of these two, right? And we're going to say there's a unit, this unit is 1, and so we're going to have the same rule set. We'll say 1 to 3 is from 0 to 100%. Does that make sense? That's exactly what actually it's inverted. From 1 to 0, yeah? Does everyone see the similarity to what I just said before? So what does this monad have to do? What's the first step? Where am I going to put my point? How do I work that out? Huh?
You have to measure it.
Okay, so what am I measuring? So I'm going to measure the distance to this point, and I'm going to measure the distance to this point, right? I'm going to say this distance is 2.3, and this distance is 5. Okay? Then what? Think about what you thought.
Figure out how far up he's got to want to put his hand to put his point.
Right. That is literally explaining the whole process of this vaguely. Okay. Remember, two brain cell men. If you tell it to go get flour and a sieve, and you pour flour in the sieve, if you didn't tell two brain cell men to then get a bowl and put it under, it'll just sieve flour on the floor. Right. We don't want very broad statements here. What do I have to do next?
Merge the results.
Merge them. Okay, now can you say merge a different way? List the results? Okay, I get what you're trying to do, but yeah, okay, list the results. So there's 2.3 and there's 5 listed. Now what do we have to do?
Would you have to find the average?
Do we want to find the average? Okay, so we need to work out which one to pick. We're going to turn these two numbers into one number, yeah? We can't have both 2.3 and 5 to find where the arm is, because there's only one arm, yeah? So we could average them, right? Or what else could we do? Okay. Find the what? The median, that's also the average, especially when you've got two numbers.
Take the smaller or the bigger.
Yeah.
The one's the one where you're going to stick your arm higher.
Pick one that's either smaller or higher, right? And in this case, what we said was the smaller the number in the system, the higher the arm. So we might say, okay, we're going to prefer the smaller number, yeah? So something that's important here is if I had a system, and this is where Logan was actually onto something quite clever, maybe accidentally.
Yeah, why not?
If we had more than two attractor points, we had 4, right? It's highly unlikely that the number that we want to pick is going to be first, right? So what do we have to do to this list before we pick it?
Rearrange.
Rearrange it? Is there another way of saying rearrange?
Yes.
I can, when you say rearrange, I could do this. Like I could just flip 6 and 5 and that's rearranged. So a more specific word would be sort, right? So if we sort them in an ascending order, we would get 2.3 first. And what index would that make it?
0.
Excellent. Okay, we're there. So we've sorted our list. We've picked out the first item because the first item is going to be the smallest. We could also do an average. And so I might show you how to guys do an average. That's going to give you a different result. So you'll see that. And then, now that I've got the number, 2.3, what do I then have to do?
And based on that number, you figure out how.
Pardon?
Based on that number, you figure out how.
Yeah, so how do what does 2.3 become? Let me just change the 2.3 to 2, okay? Just to make the maths easy, right? So what does 2 become? Right, so how do we know that?
It's halfway between 1 and 0.
Right.
2 is halfway between 1 and 3.
So what we have to do is effectively remap the number 2 with the domain 1 to 3, or to the domain 1 to 0, okay? So that, then we're going to use that to put our point on the line, okay? So, does everyone understand the process? Okay, now we're going to code it. Cool? Is this what Christina does? Okay. That's fun. This is different methods. What I like to do is explain the thinking before we do the coding. So we have a nice little map. We know where we get going prior. So that way, when I go, and now we're going to do this like average thing, or like we're going to sort, you guys don't go, oh, what's the point, right? Like we've got a nice little explanation of what the process is. So, this is going to be the difficult part. We are going to write this function without your surface, okay? We're then going to bring your surface in halfway through, okay? So, the thing that we need to actually measure distances, there's a varying amount of measuring components in Grasshopper, but the simplest one we're going to use is this guy. It's called distance. And what this does is measure the distance between a list of points. So what I'm going to do is just quickly draw a rectangle. I'm going to do that by grabbing the rectangle component and setting one rectangle. And in this case, just so that we are maintaining like a size similar to what you're working to with your models, I'm just going to make sure this is about 300 mils big. And the way I'm doing that is in the bottom left-hand corner, I can see the coordinate of my point. So I'm just setting that to 3.
The rectangle as well.
Pardon? Yeah. So, like, this might seem obvious, but the beautiful thing about Grasshopper is if a process works on one model, if the script is written well, it'll work on another. So I can explain and teach this concept with just flat points, and then we can spend the rest of the lesson like moving that into a 3D environment. Which now we gotta work, yeah. Cool, so we just made a box, and we're gonna plug that rectangle into the populate 2D component. It just randomly generates points in that box. And if you change the n value of that, it'll change the number of points. The way random numbers are generated on a computer is actually pseudo-random. So if you want a different type of random outcome, you can change the S value in seed. And you can actually, this is new in Rhino 6, I didn't know that. You can put in optional pre-existing population of points. I wonder what that does. Ah, okay, cool. It tries to do an evenly distributed randomness across. And if you put in an existing point, it will avoid putting points near that. Very cool. That's not really the point of that exercise. The point there is that we are just setting out a nice uneven grid of points, and I'm going to draw 2 points into Rhino. The key here is that we have more than one. If you want to draw 3, go ahead. Okay? But two's a nice simple one at the moment to understand. And we are going to bring them into a single point parameter component by right-clicking and then selecting Set Multiple. Do you want to know what that said?
Important.
I wish we'd get a new TV. Is the TV next door working? The problem is, I'd love to go like swap it, but it's tethered to the wall. Like it's literally locked to the wall. I think at the point where the TVs look like this, you don't have to worry about them getting stolen. Okay, so what we are going to do is measure the distance between these points. Okay, so if I plug in, actually let's just put our attractor points into A and our populate 2D into B, we get an issue. Has Christina explained to you how lists of varying lengths interface with each other? She has, but just to remind you, in Grasshopper, if I have a list which is too long and a list that is 3, A and B, right? So we have 0, 1, and 0, 1, and 2. Grasshopper, when it goes to, let's say we draw lines between these or measure distance or whatever, it's going to say, okay, let's look at item 0 and let's create the connection from item 0 to item 0. Yeah? Am I saying something you guys have been taught? Yep, okay, so when we get to 1, it connects it, and then what happens when it gets to 2? It looks at A and says, oh, there's no 2. And B, there's a 2. What does it do? Yep, it just repeats the last value of A to B, or vice versa. Cool? Okay, so we've got 2 flat lists here. So I've got like 100 points randomly generated in my rectangle. I've got 2 points outside of it. What do you think those 2 points are doing then, if I'm measuring the distance? If I create a linear representation of measuring distance, for example, a straight line, if I create a line between those 2, what do I get? Let's reduce the number. You don't have to do this. But if I reduce that number to 3, we literally get this diagram, right? Except, yeah, that's exactly what we get. So for example, the point on the left, that's connecting one line across. That's point 0 to 0, yeah? And then we've got point 1 to 2. Can you see that? So all we did is we've got 100 of those instead of 3, yeah? So there's a problem. I want this point here to understand what its distance is to both these points, not just this point, or vice versa. Does that make sense? So this is where Grasshopper makes my life very easy. And it makes your life difficult because you have to learn it. Okay, so has everyone been taught branches yet? Kind of, yeah. Okay, so if we think of a list like so, and we say, okay, this is a branch, and this is a branch, okay? So we've got 2 branches. This is branch 0, this is branch 1, and this is branch 0. So if I draw this diagram now over here as just the branches, we've got 2 branches and 1 branch, yeah? You can see that? So therefore, the way Grasshopper works with branches is exactly how it works with items in a list. So what it does is it says, I've got a branch over here, branch 0, and a branch over here, branch 0. I'm going to create a connection between them. And I've got branch 1, but there's no branch 1. So what do? So we repeat branch 0, the last branch, and therefore it creates that type of connection. So if I then look at each of these connections within branches, branch 0 and branch 0 then creates this pattern, yeah? Then we move to the second branch connection. Branch 1 and branch 0 creates that pattern, okay? So therefore, what we've effectively done is measured the distance between every point in each list. So we've created a cross-reference by utilizing the branch structure of Grasshopper, okay? So what we're going to do is we're going to graft. So grafting effectively takes a list and it produces a single branch per item in that list. So as you can see here, we've got a single branch with 2 points. And after grafting that, we get 2 branches, each with a point. And if we were to plug our graft now into our line and into the distance, we can see that that is creating exactly what I explained on the board. We are now creating points, lines between each reference point and each random point. So if I amp the numbers up on this to 5, then it doesn't matter how many points I've got, the system will generate lines between. And if I add points to this reference point, the one that's been grafted, I don't actually have to add more code to my system. The way the system works, it'll then create more lines to each point. Okay? But let's take that back to 2, okay? Because we're going to break your minds a little bit more. Cool, we got that. So we don't really need that. That's just a visual representation. But we want to look at the data that we've got as an outcome. And I'm just going to set this number back to 3. So it takes me less time to explain this on the board. So I have explained lists 2 ways to you guys at the moment. The first way is a list that is one-dimensional. It's like you've got items stacked, just like the way that you would look at a list here, right? 0 is at the top, 2 is at the bottom, and it goes in order. And if you want to break that into groups, you just put little dividing lines in between, okay? Everyone familiar with lists? Just simple one-dimensional lists. I've also explained lists as one-dimensional circles. Yeah? So 0, 1, 2, 3, 4, 5. So 0, what is to the right of 0? 1. So then what is to the left of 0?
The last
Yeah, the last one. So -1 or 5. So it doesn't matter how many we have in a list, the last item is always -1. Okay? So that's two ways that we can think of lists. When we start to add branches into this, Grasshopper has to basically display this the way that it does as a list. Okay? But we can also think of this as another way of writing data. So if I were to write down branch 1, okay, so we're going to say this is branch 1, and our indexes are here, 0, 1, and 2, right? Just like we're seeing there. So I'm just going to round, so 700, I'm not going to even round, I'm going to truncate. So 300 and 500. Right. So what Grasshopper does then is says, okay, the next list, the next branch goes underneath that. But let's just throw in a little bit of a curveball, okay? Just so that we understand it in a way that humans think, or have at least been taught from high school and primary school. If I were to say, okay, let's take the second branch and write that here. Actually, that's 0, 0, and that's 0, 1. So we've got 300, 700, and 537, 500, right? Oh, look at that, it's literally inverted. So what have I produced? I haven't produced a list. What have I made? Come on. No, you're right, it is a tree, but you're getting too advanced. Huh? What is that? What is it? It's a table! Yeah, softballing it. You put your hand out like this, like, come on, guys. But it also, I know it's stupid.
Is it really a table?
It is a table. Okay, so just to explain, when I ask you guys questions that I haven't told you the answer to, what I'm actually asking you is a super simple question. It's a question that you should be able to just answer, and it's almost like we're having a conversation. And the reason I do that is to prove to you how basic this is, because it's actually super basic. Everything that we're doing here is just us taking our subconscious brain and actually thinking about the process that it needs to take, okay? So, when I run Grasshopper, if I sort, it only sorts per group, per column in my table, right? So for example, if I sorted this, the answer would be 300, 500, 700. But that's giving me the wrong answer, right? Because remember how we were sorting the distance to the points? My problem is I don't want to know how far away each of you are to me. I want you to know how far I am, and Maddie in the 2-point example, to you. Do you understand the difference between that? Right, because from my perspective, I can measure the distance between you guys, but really what matters is your perception of me and Maddie. So, if I were to sort these, they will only sort by each branch. Each branch keeps things separate, yeah? It groups them and separates them. So, which numbers do I need to sort between for the relevant points?
The ones on the right.
Okay, so point 1 in my box, right? Point 0, sorry, is this point, right? In this list. It's also this point, yeah? So I need to sort between 700 and 300. Would you agree?
Yeah.
So the second point, what would that have to sort between?
300.
And the third point would have to sort between 500 and 500. Somehow, well, no. Yeah, in this case I've truncated, but I was about to say somehow they're the same, but it's because I've truncated it. Does that make sense? Okay, but we cannot sort by column, right? I'm sorry, we have to sort by column. We can't sort any other way. We can't sort by row. So what is something that I could do to this table to make it so that I can sort the way that we want to sort? Think physically. What physically could I do to this table?
Separate them.
Pardon?
Separate them.
No. Oh, no. Come on. I like the word, think another way. Think physically. What could you do? If I had this table, if this was the table with its columns, what could I do to make these two columns? Weave? No. Come on, guys. If I take this table and just rotate it 90 degrees, yeah, if I flip it, you're giving me a face.
Just rotate, like, why not just use those then?
Yeah, we can, because we can't. The system has to use columns, okay? The system defines the rules. We can't break the system, yeah? So we have to somehow manipulate our data to work within the system. And in this case, by rotating or flipping the table, if I think of this as a column, by flipping it, then it's going to give me the information I need. Now, the reason I got you to tell me that that's a table is there are other ways to describe tables. How can I describe a grid of numbers other than table? Think back to high school maths. Think to the Coen Brothers movie franchise with Neo. What can I call it?
Matrix.
It's a matrix, okay? This is a two-dimensional matrix, yeah? Two-dimensional matrix. So there is a function in Grasshopper called flip matrix, which will do exactly what we need it to do, okay? It's going to take a two-dimensional matrix and flip it. It will not work on anything other than 1D and 2D matrices. So if you do a 3D matrix, what's the best way to describe a 3D matrix? With a box. This ribs and burgers box or bag, imagine it as a 3D matrix, yeah? And I want to flip it. Which way do I flip it? How many different ways are there to flip it? Well, there's more than one way, right? There's more than one. So this function will not work on matrices unless they're two-dimensional, because then it won't know which way to flip it. Okay? So hopefully you've all found it by now. Otherwise, if you haven't, you can grab it here under set in tree flip matrix. And what we can see is it creates a branch structure that represents the rows of our data instead of the columns. I know I said I was full of shit at the beginning of class, like I muck around too much, but even though it seems like this is pointless, it's getting somewhere. Cool. I'm just responding to faces of people who are like, why are you explaining this?
So if we need to plug this directly into our surface, it wouldn't work.
Right now, no. We'll get there. Okay. So, now what do we have to do? What did we get to in the script? We want to get the smaller number, or we got to at least turn this into a number, just one, okay? So we can either use this function here called average. So what average will do is it'll take a list and it'll separate those lists out with the branches and give you an average per each thing. But that's actually, like, the more points you add to the system, the more boring it gets because the averages become the same effectively. So we can also use this function, sort list, and what that does is it takes numbers and sorts them in ascending order, and then we can use a list item component. We're using the default value of 0 for the I, and that will pick out the lower number of that list. $10 o'clock, 2 more hours to go. Excellent, plenty of time. And somehow we haven't filled the whole class up with people. It's good.
Those buses.
Huh?
Those buses.
Ah, yeah.
They're terrible.
Terrible. Just actually, someone from my work told me that someone is in this class. Does anyone here know Isabel Chia? Okay, it's you. Okay, now I know who she's talking about. What do you mean? Yeah, I asked her if you were in my class. She said no. So that makes sense. You're not in my class.
Yeah, I'm in your class.
Yeah, cool. Okay, so now we have to effectively determine where our number sits in our rule set. Okay, so we need to make a rule set. What was my rule set? Stick your arm up high if it's at least 1 meter away, and if it goes to 3, then stick your arm down. Okay? So we have to then define that in this script. And the way that we want to do that is by creating a domain object. I've used domains with you guys, my class. Do I need to explain it to Christina's? Okay, so a domain is an object that just describes something that goes from one number to another number, okay? It effectively is a really easy way to store 2 numbers in one object, okay? So if you need a cheat down the line where you're like, I need these 2 numbers to be stored together, you can just stick them into a domain and they stay together, okay? But something I want you to understand about domains, they are not going from a minimum to a maximum. They are going from one number to another, okay? So that means you can have a high number first and a low number second. Okay, so do you remember I said if you are 1 meter away from me to going to 3 meters, that goes from 100% arm up to 0% arm up, yeah? So what we've done is we've mapped a small number to a high number and a high number to a small number, yeah? Because if I said stick your arm up based on the distance you are away from me, the further away you get, the higher up your arm needs to be, yeah? So we've inverted it. And you don't have to do this is where this particular assignment gets really interesting because the variables that go into the rule set can change drastically and create weird outcomes, okay? So we are going to create a domain that effectively defines our 0 to 1 because we want to use 0 to 1 with a function where I'm about to explain. And we want to construct a second domain. Well, if anything, this is our first domain, and this is actually going to represent distances in reality, okay? So in this, we are going to chuck a slider. Let's make it go up to about 700, seeing as that was a number that I saw was quite in the system. So what I'm going to do is I'm going to actually reverse it because I actually probably want to keep this 0 to 1 as 0 to 1 because it just saves us having to code more. So we're going to put our high number first. So our high number goes first. And our map target is going to be 0 to 1. And we're going to use this component here, remap numbers, which effectively saves us from having to write all the addition and multiplication and division functions that you would need to do. Like if I said, okay, find the number 2 in between 1 and 3 and work out where that sits in between 0 and 1, like we can quite instinctively just go 0.5. But if I said 2.235, then you would have to do some addition, like you'd have to subtract 1 from 3 and then like get the percentage. This little component saves us from having to do that. So by plugging our numbers in, we have a source domain, which is going to be the real values, the dimensions, and our target domain is going to be this 0 to 1. Those of you who are very perceptive will realize that target domain is by default 0 to 1, but let's just cover all our bases just in case the defaults change. And the result that's going to give me is those numbers as a percentage, effectively. So just to demonstrate, if I just quickly throw my points into a line start distance length, distance being y, so z, so it's almost like this line going up is like me putting my arm in the air. If I plug the length into the L factor, we can see as I move my points away, these lines get longer and longer, yeah? And so, cool? Okay, so what we need to do is convert that to something that isn't like a distance. We need to convert it to something like a height that we care about, yeah? But, let's do it. So I've remapped these numbers to 0 to 1, and you're going to say why? Because what I want you to do now is I want you to remap these numbers from 0 to 1 to numbers that we actually care about. And I'll explain why in a moment. So in this case, let's say if something is literally right next, like on top of each other, or if I set that to 100, if something's 100 mil away, right, we want it to stick up 700 mil, yeah? And if it's 700 away, we want it to stick up 500 mil, yeah? So what we can see here now is, because these are all literally, it's worked. So that's then going to give us these values, which we can then map. So let's just use this line SDL. We need to make sure that our data structure is flat. So flattening is the opposite of grafting. So we are going to put our grafted numbers into the flattened tree. We're going to plug that into the length, and we're going to put our start points into the start values of those lines. And as we can see here, as I change the minimum height of the outcome, it will control those lines. So maybe an easier way is actually now to increase the number of lines. So if I set that now to 100. Pardon? Yeah, so these populated 2D points, we're going to plug them into the S. So you can see we're getting sort of like this 3D shape. And as I play with these variables, it effectively defines what the minimum and maximum values infer, okay? So, really important thing, did I get you guys to put your arms lower if you were further than 4 meters? Did I? Lower. I said 3 meters, let's say, was at 0, but I didn't say then keep going, go to -1, right? I didn't want your arms to go through the floor, yeah? Plus, can you put your arms up higher than 100%? No, you can, I know, like, you know, we can motivate you to go 110%, but you'll only ever get to 100, right? So, the cool thing here is when we remap these numbers, if your number goes above or beyond your domain, it will remap that to above and or below the target domain, okay? So if I said give me 11 between 0 and 10 to 0 to 1, then the answer would be 1.1, yeah? So fortunately, with these remap numbers, the clipped value will give you a floor and a ceiling based on these construct domains. So as I get to a certain distance away, like if I put these so far away that they should technically make this thing massive, we can see that there's a ceiling, there's a clamp effectively put on the height. Cool? Okay, so last thing, why did I use 2 remaps? Why didn't I just plug this number into the first remap? Why did I remap it to 0 to 1? The reason I did this is because if you use this particular component called graph mapper, which is a fucking boss component, okay, this component works really well when you have a number that goes between 0 and 1. And I'll show you exactly what it does. When you plug a number into graph mapper, by the way, right click graph mapper, go to graph types, and that will then, you can tell it the type of graph. I'm using linear at the moment. When you plug a number into graph mapper, that number determines where on the graph the graph mapper is going to put the x dimension, okay? So x is currently at 0.5. We will get a red line running through x equals 0.5, yeah? The outcome of graph mapper then gives you the y location on the graph. So on this just 45-degree angle graph, x equals 0.5 is going to also equal 0.5 as y, yeah? But if I change this now to this parabola, right, just to keep things relevant to what we're doing in this class, then what does x equal on the y-axis of that graph? 0, right? Cool? Okay, so what this does is if we insert this in between our clamped remapped numbers and our new remap, what it will do is effectively change the fall off. So if I right click this now and set this to a sine wave, then we don't get a conical relationship between our points and their effect. We get a sine effect. So if I quickly I'll move one of my points away so that you can just see the outcome from one point. If I then see how that fall off isn't linear? See how it's got some, like a nice sine curve to it? What it also means is I can do shit like this, right? So the fall off isn't necessarily, like it's a multi-sine wave, yeah? So that's giving us an outcome. Maybe it's better if I just get the endpoints
How did you do that? Sorry.
How did I do that? Do you have the graph map?
I do.
Do you have it set on sine wave?
I do.
Then you can grab these little dots as handles and begin to play with that fall off from that point. Maybe this is easier to, see. Wow. Cool. And so just note that you can always, if you want to throw average in, so if you grab C average, if you throw that in there, that you're going to start getting much more gentle results, which you might not want. Cool? Excellent. So we've done something super cool. Now we just have to apply it to our surface.
Can you just go back to the where you evaluated the curve? I see you literally just plugged that in.
I've just put evaluate curve in just to give the endpoint, but the lines are fine. You can use lines. Okay. So why? What's happening?
Well, because it's just giving an error. Failed.
You've plugged. What's the outcome of your flattened list? So a really good one, I think, is the Bezier one. It effectively gives you can grab the handles of your, like a Bezier curve, and you can effectively determine whether or not you're going to get peaks or soft valleys. Is it working now, Joseph? So this doesn't have to be a line. We could be drawing circles with a radius. And just make them smaller. This is probably easier to see, right? So as I play with my points, see how that's making like an effect on the system. It's effectively telling my circles to fuck off. And if I play with the fall off, then I can get my points in my system to create cool, wacky patterns. Cool?
You know how you set that challenge for us a while ago with the living hinge?
Yeah.
Is this how you would have done it?
Yeah.
Right.
You know, somewhat, yeah. That's why I said, if you can do this, I'll give you 100. Huh?
The challenge still applies?
No.
Do you have a circle?
Yeah.
Okay. So we've made an attractor script. What Christina wants us to do is effectively create a perforated object, okay? And the simplest way I can think of doing that is by working on the panels of that object in 2D and then migrating them to 3D, okay? So what we are going to do is we want to create a panel system for our surface. So the way we will do that, hang on. I don't want to break your brains. There's a lot that we could be going through right now. I really hate to do this. Like, I hate this, but it's just what we're gonna have to do. There's just not enough time. I want you to go to a web browser, and I'm gonna introduce you to probably one of the best and worst things you'll ever get taught about Grasshopper. Okay? So just remember this. This is a double-edged sword. I want you to go to foodforrhino.com. In the search, I want you to look for the thing called Lunchbox. And go to Lunchbox. Lunchbox is a Grasshopper plugin, okay? You can get, so Grasshopper is a plugin for Rhino, and you can get plugins for Grasshopper. And they're mainly free, okay? Most of them are free. Do we like using free information for our papers?
Yes?
So if I go to Wikipedia,
No.
and I reference Wikipedia in my paper that I write, what's going to happen?
You get marked down.
Why is that?
Because it's not 100% accurate.
Right, we're not sure if it's accurate, right? There's the moderating system for Wikipedia isn't strong enough for academic research, okay? We're not absolutely sure that these plugins are accurate, okay? So they're free. They might do things a certain way, and if you don't know how to critically analyze them, then just be really careful with them. And the reason I don't like Lunchbox so much is that it allows lazy people to do things like what I'm about to teach you. So just know that I'm being lazy, okay? And that one day I will try and teach you how to do this. Actually, I'm not going to teach you guys this because it gets taught in the next semester. So it's just know that this is the lazy way, and that learning how to do this yourself, this particular process, is much better than just relying on Lunchbox. But in this case, we're going to use Lunchbox. Okay?
Which one do you want?
So we are going to download it. You want the latest one? And this is also a nice little lesson on how to install Grasshopper plugins. You'll need to save your Grasshopper script because you will need to close Rhino for this to work. But don't close it yet. Once you've saved it, go to the components folder. So you can do that by going File, Special Folders, Components folder. It's in this folder that you need to place the download that you've just saved from Food for Rhino. You know all of this?
Yeah, we have to get to
Did you guys already use Lunchbox?
Yeah.
For what?
the living ends. Yeah, unroll VRAMs.
Ah, okay. That makes sense. Yeah, I didn't use that. I taught my students how to do it the real way. Sorry, guys. Sorry for teaching you the fucked up way. What they had to do was measure the angle in 3D between a high resolution of triangles in the 3D shape, and then find the compounded, so if that's 1 degree and that's 1 degree and that's 1 degree, then add them together to create lines with that angle and these distances, effectively then recreating the 3D surface in 2D.
That sounds a lot more complicated.
It is, but I taught them how to measure angles and how to map things from 3D to 2D.
Yeah.
So that's the benefit of teaching it. Oh well, that's fine. Either way, we're going to use it today because I don't know if I even got it. Do I have it? I hate it that much. No, I do have it. Okay, we're going to use this to create. We're going to create like a pseudo environment. No, are we? Yeah, we are. We are. No, we're not. No. Okay. So what we're going to do, guys, is we're going to then we're going to work with our surface. Okay. So I want you to go grab your surface.
Where do we have to save Lunchbox?
If you go File,
Oh, I know. It's installed.
Special Folders, Components folder,
That's where you save this, or you save Lunchbox?
Lunchbox.
You should save this normally.
Save it wherever you want.
Okay, cool.
You can save it in your Components folder, but
And then what do we do when it's in there?
you have to restart Rhino.
You have to install it.
7%
7% installed.
installed. Oh. Okay. Lunchbox has changed the way that they install it. So instead of so most plugins that haven't put effort into making a little install thing, you have to paste in.
Right.
But in this case, this has got an installer. So you got to run the installer and then restart Rhino. Cool.
You can't use Lunchbox on Mac, I don't think.
Pardon?
I don't think you can get Lunchbox on Mac.
Okay.
I'm just getting an access.
So what happened with your Unroll thing then?
I have a desktop at home.
Yeah, I like to use them for
Okay. So does that mean that you're a bit screwed at the moment? Okay. In this case, for now, there is a cheat for class. It means that your outcome is just going to be a bit boring for class. But if you can get this to work on a Windows computer, that's great. Or you can just rely on the boring outcome. That's fun. Boring's good. So with the Surface that you've got, this is just for those of you who are using Mac right now, or not. If you've got your geometry, we've got our Surface, right? We're going to plug that into a thing called isotrim. And we are also going to grab a component called divide domain with a little 2 squared. If you plug your Surface into the I of that, and then the S outcome into D, then what that's going to do is divide your Surface up into little iso surfaces. This is only for the Mac people. I guess it's going to do exactly. Well, we can work with it. Okay, so if you've got Lunchbox, then instead of doing that, you can literally choose one of these panel systems. So, for example, hexagons are cool. So let's plug our Surface into the hexagon one, and it will generate hexagonal surface panels for you. And in this case, this broke. It's not. Oh, okay. Yeah, let's do this truncated. Okay, so those of you who are using Mac, if you grab your ISO trim and then plug that into a curve component, that'll generate a curve edge to each of your panels. In the case of the hexagonal cells on Lunchbox, that'll create a curve boundary anyway. It's not going to create a surface, which is dumb, but whatever. But if you use diagonal diamond panels, then your diamond panels will need to be plugged into a curve. So, we'll just, we have to work with curves today in this case.
Where do you find those shapes?
Yeah.
In Lunchbox?
No. Oh, are they Lunchbox?
Yeah.
Oh, we're working in Lunchbox now, are we?
We're going to, so now that it's installed a plugin, your plugin will show up as a little tab in Grasshopper. That's how you know it's installed. Okay? Those of you who didn't have it installed, can you see that tab now?
Yep.
You can? As you can see, I've got a shit ton of plugins. Yeah? Like, this is the very last vanilla grasshopper thing. This one here, the display one. And then every other letter after that is a plugin. So in this case, I know Lunchbox starts with an L, so it's probably this one. Cool?
So we're supposed to be creating a geometry in there? And
You need to either use the surface that you worked with last, that we made 2 weeks ago.
right, okay, so we're back.
But
Just the one surface.
yeah, we'll just work with one. We don't want to overstretch our brains. We all good?
Yeah, mine doesn't seem to be working with my surface. The one that
It doesn't work.
it's saying the surface is invalid because the trimming view domain is singular.
Okay, so if you've got a trimmed surface, guys, just plug that into a component called untrim. And then use that untrimmed surface instead. Does that work now?
Mine is sort of following sort of where it would have been if we hadn't trimmed it. Does that make
Excellent. Perfect.
sense? That's what we want?
Yep.
Okay.
Mine's still
Okay, I'll come help you out. So guys, this thing works on surfaces, and for my class, you've probably heard me say this once, and I said I'm going to repeat it over and over and over again. How many sides does a surface have? 4. Surfaces always have 4 sides, and so this function effectively relies on the fact that a surface has 4 sides. So even if you have a trimmed surface, this thing's going to produce an untrimmed result. Okay, so what that means is if I'm just going to I'm going to assume that mine is trimmed. Okay, so I'm just going to trim my surface quickly. That looks cool. Nice little Pringle. So we can see here, even though we've trimmed it, that it's going to produce like a grid across that whole surface. And what we're going to do is take that trim and use that in the near future. Hello. Okay. Do you need to plug it into the wall?
No, it's still good.
So you've untrimmed it. Oh, you're just using the wrong domain.
Oh.
That's okay. Cool.
Yeah.
So the U and V, that's just the number it divides by in both directions. Cool? Okay. Huh? Can you get that? Can I get some of that? Let's just hide everything. I love Mac. There we go. You just have to say that and then it works.
Yeah, so this is my script from 2 weeks ago, though, by the way. I
Cool.
brought in.
Okay, we only want one. Okay, guys, we're only working with one surface. So in this case, you want to be working on this one. Cool? Done.
We don't want to take the whole thing like that.
Yeah, we're going to work on one surface. Just let's work on one surface, because if we work on more than one, your little brains will fry. So you should have the point where you rotated them. It's the item just before you rotate. We all good? No, we're not good. Why?
I just need to put all this other one.
Have you done this?
Yeah.
So you just need to plug in a curve. You don't, guys. The only reason I've got these two guys, they're just there This is the Mac process. This is the Windows process. Windows could be anything with Lunchbox. Okay, so you don't need to do both. Cool? Okay. So we've got these cool little surfaces, little curves, and we've got a function up here that tests. This is the thing that made our attractor script, right? So what we can do is we can use that to play with these curves and actually do something with them. Yeah. So one method is by offsetting. Now, everyone's this is effectively what Christina was thinking in terms of offsetting. So, what is the method that we've used in the past to offset? We've had a curve. It sits on a plane, and we have a value, and it offsets on that plane. Okay. Fortunately, there is another method for offsetting, which is offset on a surface. So instead of using a plane, we can use a 3D object, a surface, to define our offset plane. So if we go grab offset on surf, and now it's at this point that these two can effectively, we're moving back into universal territory, not Mac and Windows territory. We define the surface that we're going to offset on. So that's this untrimmed surface here. Huh?
We need the untrimmed.
Yeah, well, what untrimmed does is just make sure that we're working with the untrimmed one. We are eventually going to trim it. And I'll just hide this. So what that gives us is the ability to very slowly, you can see here, this is almost taking a second. So this is when we start to kill my little Ultrabook. So if I then plug in the number 20, I can hear it. It's in pain. So we begin to get this, it's almost like a mesh, right? And so just to cheat this solution at the moment and not to kill the computer completely, if we graphed both the outputs, and actually if the offset on surface is going to graft, what's going on? No, that's right. Then we can loft between them and probably get a broken result, but let's see what we get. And we just need to simplify these graphs as well. Ta-da! We get a perforated shell. Huh? Huh? I did not get a perforated shell. And if I plug in my ISO trim, that should do the same. Yay!
Hang on,
Can you?
Where are you pulling the S from?
The S is our untrim.
That's our untrim, okay. So that's fine. Then what's it going there? And then the grafting's there, yeah.
Yep, so we...
I see what's going on.
Yeah.
I've got broken off.
Oh,
Yeah, that's okay.
I've got like a mesh around the edge, but nothing in the middle.
Can you just play with the number a bit?
Yeah.
The offset number? Logan, does it work now?
Well, I don't know. My computer's frozen while it's
Yeah.
processing.
Yeah, it's fucked. So we could do this in 2D, but the process of mapping it from 2D to 3D is a process that takes more than an hour and a half to explain. So we are going to do that in another week. Next week, I think.
But we're not 3D.
No. Today, we're going to do it this way.
Oh, and then go.
Next week, we're going to teach a different thing. Now, it's one of my favorite lessons. I think have I already taught it? I think I have. Have I done the whole Google Map thing yet? Have I done Google Maps with you guys yet?
Yeah. No.
No, okay.
What's the question?
Nothing? Never mind.
I was too busy.
Okay, so our monad in this case is going to be our panel, yeah? And the parameter that we're going to change of that panel is going to be how far it offsets, yeah? So the more it offsets, the more we're going to get like a funky outcome, yeah? So what we need to do is somehow take what we've written here with this random point system and stitch it into our panel system, yeah? So the key thing here is that the distance of our offset on surface is going to be the thing that effectively takes the attractor points, right? And what is going to determine the point that we measure to? Can anyone have a guess? Just so that I know that you're actually listening and understanding what's going on. So if we're going to take these panels and we're going to turn them into an attractor system. What did we need to start the attractor system?
2 points.
And
Distance.
between those 2 points and all your other points. Do we currently have points? So what do we need to do? We need to get points that effectively determine where our panels are. What's a super simple way of doing that? We can get the centroid of those panels, okay? So we can get centroids of panels using area. Now, I know these panels aren't going to be planar, so it's not actually going to give us the area. It's actually also not going to give us the center. So what we need to do is use area moments, I think. Nope. Let's try volume moments. Nope. My bad. This component here gives us centers of a hexagon. For our Mac users, when you do the isotrim, just before you do a curve, if you run the isotrim into the area, that will give you the center of each little square.
What if you used one that wasn't the hexagon that doesn't give you centers?
If you use one that is it creates surfaces, then you can use this same process. So for example, if which one did you use? Triangles. Okay, the beautiful thing about triangles that the panel's outcome are surfaces, right? So you can plug in your area into that. Guys, if you're ever in a situation where you're trying to find the center of a 3D curve that doesn't have a surface and you're trying to find the center, guess what? It's impossible. It doesn't exist. Those centers don't exist, okay? But a cheap and easy way if you feel like, as long as it's close enough, it's good, then if you explode that curve and get the starting point of each of the lines, like so, and then you find the average. So Grasshopper's really cool because not only does it let you do averages on numbers, it also lets you do averages on points. Then the average of those points, the starting points of each line, should be fairly close to the center of that object. Should be, right? But if you have an object like this, right, there's all these points up here, and there's only like a few points down here. So these points are going to skew the average and send the point up, okay? So just be mindful of that. Cool? Look at that. We're literally creating like 500 different ways to do this.
I've screwed it a little bit like this, so split list item.
Oh, we don't need to do this. You can play evaluate that.
No. It's just me. Yeah?
I've screwed like just a few components leading into the untrim. So,
going into the untrim.
yes, you had the geometry set of split list item.
Yeah. So this is just me setting up a situation similar to what you should have. Okay. So all you need is your surface prior to it being rotated, plugging into untrim.
No, divide them out.
If I was to plug my 4 points, like all my points in now, would it crash my computer?
Pardon?
If I was to plug,
If you were to what?
risk it.
I just
It's crashed it.
crashed my computer. If you were to plug what?
Doesn't matter, it's crashed anyway.
Okay. It always crashes. Okay, so these center points, either by getting them through the area or getting the centers or whatever, as long as we get the center points, we need to make sure that there's the same number of center points that there are surfaces or curves. So I've got 61 curves, I've got 61 points. Beautiful. They're the same. Okay. So what these are going to do, these points, they're effectively going to replace the 2D populated points that we've done in the attractor script. Okay. So what we are going to do is grab the point parameter, get these populate 2D points, hold Control Shift and drag those down, and we're going to use them instead. What's up? You got this face like what? It's crazy. Did you not know how to do the drag thing? Control Shift? You knew that? Okay, so what? Okay, you just didn't. This is why teaching like a class, like face to face, is so much more important and better than like teaching it online. Because I can see that you understand or not. Like, I can see if you're scared. Like, I get one student in a previous year, and literally actually similar to you, in like their face was always just like, oh, this is too much. No, it's good. It's good. Like, it's useful.
Mine's completely cooked, by the way.
Okay, good.
Yeah, so we're on.
Yeah, that's worked. Your offset. Oh, fuck me.
Yeah, the scroller broke.
Oh, wow.
You can only zoom out. How do you intend on zooming?
I use this bit.
Right. I think you can select these and you can use that zoom selected.
Oh, okay.
If you select something and then click that, that'll help you.
Okay.
And then you can zoom out. So when you offset something, you want it to offset by distance.
I thought we were on the down.
No, this is the up bit.
Oh, we're back up again.
What's this?
I remember you said there was a slope back. It's really hard, then it gets easy and it goes up again.
Yeah.
We're back up now.
Yeah.
So the down was only 2 weeks.
Yes.
Okay.
You remember? Yeah, I literally, I was being serious. I knew.
There's another down bit coming.
There is a down bit coming.
No, there's no more down bit.
Is that what it is?
These just got to simplify. You cooked it. It's not cooked. There you go.
So what about this area?
The area. So we want to grab that from when you do the subsurface.
Yep.
That's just giving you the center point, right? So those center points now need to go. Like we're going to stitch that process into this. Okay.
Oh, okay.
So guys, just to get back on track, yeah. The center points that we've collected of our panels are going to be it, through the area component or through the center points of the lunchbox thing. They need to, if I undo what I just did, we're going to take the populate 2D points and we're going to replace those 2D points with the center points of our panel. Okay? We're good?
I don't know why it's not on circle.
What's the matter?
I don't know why this geometry is not on this.
Guys, so we're working with the untrimmed surface, okay? So even though you've trimmed it, right, we want to work on it beyond it. Because the problem is, if we don't do that, we could have a trimmed surface that looks like this, right? But we've got a hexagon that looks like that. So we can work with these nice simple diagonals or triangles across it and do the offset, and then we will retrim, okay? So once we've finished working on this, we'll retrim it to the shape that you originally had, and everything will be hunky-dory. Cool? Yes?
My loft service isn't showing.
Guys, just note, I did I right-clicked this graph tree and I set simplify. I will explain that. Is it working now?
Yeah.
Good. Okay. Huh?
Grab the point from the 2D, grab those two ones and pull them out. Where should we plug?
Get a point. So we want a point that either goes out of the area component, you know, this center point, and we're going to swap our 2D points for that. So the way I did that was I held Control Shift and I dragged the output of that into our center points.
Yeah, so all it's doing is just changing the size of the circles in the middle of our hexagon.
For now. Yep. What we're going to do is we're going to use the radius that we've set for those circles, and instead of using it as a radius, we're going to use it as an offset for our panel. Cool?
Sorry, can I show how to do this circles again?
Pardon?
Can I show how to do this circles again? I kind of lost it.
How? Say the question again.
I kind of lost it. When it was halfway doing the circles.
Circles?
Yeah.
How do you do the circle thing? This thing, the circles. Don't worry about that. We don't need circles. We're going to. Do you have this? Do you have graph mapper, remap numbers, and flatten tree?
It only shows the straight outlines.
Yeah, that's fine. Have you got the number that goes into the L?
Right.
That's the number we're going to use. Okay. So guys, we've got our attractor points. It's probably best to put them somewhere relatively nearby our surface, because if they're not, then we're not going to see an outcome. And the way offset surface works, offset on surface, it's killing all of our laptops. So we want this to be as quick as possible. By the way, the less panels you have, the faster it will run at the moment. So those Mac users, if you lower the number of your U and V count on the divide domain, that'll reduce the number of panels you've got. Or if you reduce the number of U and V in your lunchbox component, that'll lower the number of panels.
Stick it on a strong one.
No, don't. Do more than one. Okay, but that should... I literally have to slow down because of the computers now, not because of comprehension. Okay, so I can see here that my offset is... I've put in an offset and 9.2 seems like a reasonable offset. So we can see here, I've got this set to 28 to 0. So I reckon that's going to come out with the 28 to 0 is effectively the target domain of my remap. Yeah? So that's going to be roughly the same as what I need for these panels to work. If it's too high, then it probably will break the script. So we just need to be careful about that. And as well, we're going to 3D print this and we can't have an infinitely thin panel. So we need to set my minimum to at least 2 because when we 3D print in the Fab Lab, we want a minimum of a 2 meter wall thickness.
No.
Correct?
Yes.
At least 2 mil.
Yeah.
Yeah. If you can go more than 2 mil, that's better. But in this case, I don't actually have to 3D print this, so I'm going to set it to 2. And fortunately, if we just check so get rid of the lines, get like that line SDL and the circles and whatever, get rid of them. All we need is this flattened tree. If we check that flattened tree, we can see that has 60 values in it. In my case, in your case, it'll have a different number. And if I just go down and check my curves that I'm offsetting, that has 60 curves, right? I have 60 values for 60 curves. Brilliant. So if I plug my flattened tree now into my offset on surface, I get a broken loft, and I have to solve that. I'll solve that in a moment. But what we can see is that we've now begun to affect. So you can see this particular offset here is quite small, and the offsets in the middle are quite big, and that's because of this distance thing that I've set. What did I do? I plugged my flattened list of values into the distance of our offset. And guys, just to guarantee that we get a result, if we set the t value of our graph tree to flatten, oh, it's all fucked. Then I'll just, maybe my offsets are a bit too aggressive. Yeah. I just had a very aggressive offset, that's why.
Change the maximum of the thing, slide the maximum type and slide.
Pardon? If you double click the name of the slider,
Yeah.
then you can then set the minimum and maximum. I hate this. How do we solve this problem? How would I solve it? By myself. I wouldn't flatten, I know that. Fuck you, component. Why do you do that? Okay. Oh, okay, that's why. So guys, the reason this is breaking is I've got more than I actually get more than one outcome for some of these components. And the problem is this guy here is just too small to get offset properly. And some of you will find that, and in this case, if you can solve that yourself, please try. But just change the division, and that'll solve it. Okay. So in this case, my hexagon pattern, if I change that to a if I use this particular one, so if I use my ISO trim, that's working quite well, right? So like I can play with that offset quite strongly until it breaks. No, but I don't have shapes that are much smaller than the others. Come on.
So if you just turn your what's it back up again, you use these, you get more shapes.
Yeah, and so that, and then if I set that minimum to 40, that's going to have a much bigger effect on the system, or 100. 200. Serious? Is this because... And that's going to work in 3D as well, guys. So, it's just because I've made mine big. Okay. So now we need to make this printable. Do we all at least have something that resembles something like this?
My sliders don't really have any.
Don't look at the sliders. Look at this outcome. We all have something that has a perforated shell. No, you don't. What do you have currently? Can we just use this process for now?
Yeah.
Can you hold Control Shift? Excellent. Cool.
So just full or have
Can you do the same thing? Can you use that diamond one? Can you show her how I did that? Yeah. You're all gonna get the same thing. Just guys, the hexagon thing, it didn't work out because of the way the hexagons go to the edge. So guys, my suggestion is instead of using hexagons, just let's keep away from them at the moment. If we go to, let's use diamond panels instead. So if I plug my untrim into the surface of the diamond panels, and then we are going to grab the area of the diamonds. So the area is going to give us the centers, which goes into the point, and the diamonds go into the curve, which becomes the curve objects, and that should give us a nice little diamond system. Cool. Are we all good now? Yeah? Okay, good.
Hang on.
Oh yeah, C. See that, C.
So Mac won't be able to do that. Because we don't have the...
Yeah, but Mac, because we did it with an ISO trim, it should work. It should be working. You shouldn't have had all the problems that I've had, right?
Yeah, this is doing loads more stuff.
Mine doesn't seem to have the same level of variation.
Right, so that's because you need to play with these variables. Yeah?
Do they seem to do like I've seen
Are your points near your model?
points?
The points that we're using to do the attraction, are they near the model?
The initial ones. Can we? Like, how do we reset them?
In Rhino, you click them, and then you hold onto them, and you move them. Excuse the sarcasm.
I've unselected everything I can't.
This is just
to the left.
This is just adding layers to the, like you've already learnt attractor scripts. Now we have to 3D print it. It's just adding all this shit on top of the actual process to just prove that you know how to do attractors.
The script isn't good enough.
No, it's like you've learned attractor scripts. I'd much rather you show me attractor scripts without having to do like offset on surface. Like offset on surface is slow, and it means that you guys are less likely to actually experiment with the attractor script process. So yeah. Okay, it's at this point here, loft. If you flatten your loft output and you B-rep join that, that'll create a open B-rep because all your surfaces should be touching each other. Now, we could actually, if you want to, you're welcome to go and start extruding your panels with a attractor script. Okay, you can start layering attractor scripts into this, right? But in this case, if we just B-rep join this and then throw in an extrusion like so. So if I throw in a Z vector for my extrude, and if I set that to a minimum of 2 millimeters, because we're 3D printing, then the outcome of that is going to give us a nice solid B-rep. Okay, so there we have, see how it's giving us that solid outcome?
Where did you put the 3, sorry?
The 2?
Or whatever.
In the F value, sorry, it's a force of habit. We put a number into F that will then set the thickness of the extrusion.
I would go with more than 2, by the way, because when you got to get it off the supports, you want to make it thicker so that it doesn't break. If it's only 2 mil and you're trying to get it off the supports, it's gonna
Live life dangerously, guys.
all safe.
What would you say was a safe number?
I would say
4?
10 millimeters is a safe number.
No, 4 is probably. 4 or 5.
10's also a safe number. 10's higher than 4.
Yeah, 10.
Yeah.
10, right.
That's a good way of getting up with extruded line.
So if you wanted to put another attractor script in, can you just copy the other one that we did and feed in the points? What point do we feed it?
Other points. You could do other points.
If you wanted to adjust the...
You want to use these same points, then you don't have to copy the whole script. You only have to copy this
that
bit. Okay, and you wouldn't...
bit. Even the first constructor made as well, or just the second bit?
well, if you copy this bit, then you then change, you can play with how far the points are affecting the system.
Okay,
Does that make sense?
right, so if you wanted to do it so that it extruded at different heights
Yeah.
up,
Do we want to do extruding at different heights?
Sure.
We've literally got an hour to do it. Yeah, let's do it. Let's do it. Today, we're going to finish our class on time. Okay? We're going to be on time. Because I have places to go. Okay, instead of doing this B-rep join then, we are going to extrude our panels. Okay? It just means that we have to do the B-rep join process later, okay? And it might break because we have to use this function called Boolean union, and Boolean union is a fucking pain in the ass. And we're going to see that in probably next week's assignment. You guys are going to be like, fuck Booleans. But we'll see if it breaks it today, okay? We'll see. I don't think it will. We'll see. I'll deal with it. We'll see how to deal with it. Okay, so we've made this attractor script, right? We can actually reuse it if I hold shift. We can reuse it. If we copy and paste this section here, and you can choose how much you want to copy because you might want to maintain variables from this. But if I copy and paste this, and I then plug my flattened tree into the Z vector of my extrude, you can see we are now extruding some, like the values that are with the thin offset as a small extrusion, and we're extruding the values with our thick offset with a thick extrusion. Now, the way structure works, this should actually be inverted. Our thin value should be at the top and our thick value should be at the bottom. But whatever, I don't have to 3D print this, so. Do you understand what I just did? Now, if you, instead of copying that, copy the whole attractor script, including the start points, that means you could have your extrusions controlled by a different set of attractor points, yeah? So instead of having like a thin filigree here, you could set the thin element to be at another point in your form and have that be a different layer to your other attractor script. Does that make sense? Cool. I would encourage that. That would mean that it would prove to me, at least, my class, that you understand it more, okay? So the more you can layer your attractor script up whilst not making an ugly outcome, the better. Cool? Okay. So we've got our extruded shapes. Now we need to trim them to get that back to the shape that we had originally. This is where it gets a bit fucked, okay? We've already done the offset on surface, and that started to kill our computer, right? Let's see what Boolean union does. I need to explain what Booleaning is actually, don't I? Because you guys don't know. Are we all familiar with what a Boolean is? Like, yeah, okay. So, Booleans are true or false. That's it. That's all they can be. So the way Boolean functions work are you familiar? Okay, before I get into that, Booleans can also be put through operators. So similar to adding, so like adding two numbers, 1 plus 2 equals 3. We can do operators to Booleans to get an answer. So for example, I can take 2 Booleans and I can run an AND function on them. So we're all, no one here is gender fluid? No? Good? Okay. No one here is age fluid, right? No? And I'm guessing the average age here is about 20? Okay. What's your age? 21? 20? 20. Okay, so we'll stick around 21. Okay. So, I'm going to ask you, are you male and greater than 21? Okay? So, are you male and greater than 21?
No.
Are you male and greater than 21?
Yes.
Right. Okay. So, in your case, are you greater than 21?
No.
Okay.
Oh, I am.
Huh? How old are you?
21.
Okay, we'll say greater than or equal to 21.
Yeah.
Right, so in the case Maddie was true here, but false here, right? In the case of a true and a false, with AND, the answer is false, right? Because Maddie is not male and greater than or equal to 21. But in the case of Ashley, Ashley was true for both, so therefore we end up with a true. But if I were to change that and set it as or, are you male or greater than 21? So you're younger than 21.
Yeah.
Okay, but this is good. So we've got, this is perfect. So in the case of or, Maddie was false for male, but she's true. So you male or greater than 21?
Yeah.
Yeah, okay, so that's true because one of them ends up true. In your case, you are both false and false. So in that case, the answer is false. Okay, so we see these operators. My phone just went off, so I just need to check if it's recording still. It is, and I'm going to just set that to serious. Is that still recording? Yes, good. Okay, so when this comes, so we're familiar now with Boolean operators, and and or. Cool? Okay, so when we come to Boolean geometry, and this only works on geometry that is closed, so it only works on closed curves or closed solids, right? So if I have two objects, we can think of that in a similar way to male and greater than 21, right? So instead, let's think of that as A and B. When we do a solid union, what we're asking it to do is look at each of these elements as a segment and treat every single one of them as if they were true. So this one would be true, true, and true. And so the resulting outcome would be a shape that looks like this. I really should work with boxes instead of circles. Okay. So then, when we do a solid difference, what we're asking it to do is it's almost like a AND function. So we're saying, okay, true, A is going to be true, and B is going to be false, okay? So where A and B overlap is like me asking Maddie if she's male and over the age of 21. So in A, this A section here is true, right? But the B section is false. What happens when we use AND? What overrides the other? It's false. So if we do a Boolean difference, we basically get rid of everything that is false, and therefore we'll end up with a shape like so. Okay? And the intersection one's a bit screwy because what it does is it says that, oops, these need to overlap. What it does is it says that when you set everything to false, and when you have two falses, they actually cancel each other out and make themselves a true. And so the outcome is the intersecting shape. Okay? The point being, everything has a 3D segment to it. As in, it breaks into 2D or 3D segments, and the system effectively determines whether or not that segment is true or false. Okay? So when we do a Boolean solid union, that's taking all our objects, finding where they intersect, and setting all of them to true. And hopefully, we should result, yes, excellent, love it. It should result in a single closed object. What did yours do?
Mine's got like just a new line item. It just says close zero, close zero, close zero.
Can you? Is it flat? When you see your loft, right-click loft and make sure that's flattened. See, dude, look at my screen. See the loft? Right-click the outcome and flatten it.
Yeah, mine's flat. Mine just says Boolean union set is empty.
Yeah.
Yep, that's what I expected. Okay. Okay, if that's happening, then there's a few ways to solve it. We can go to right-click the unit settings of our Rhino model. See the absolute tolerance in unit settings. If you add zeros to that, the more zeros you add to it, the slower your script's going to become, but the more likely the Boolean will work.
Where do you go? Sorry?
You go to the unit settings in Rhino, right click that. The more zeros you add to that, the slower the script will come, but the more accurate it will be. Otherwise, you can just give up. That is a solution. And so if you do that, if in that case, instead just use the BWrap join on your loft, your flattened loft. When you extrude it, just extrude it with a single value, not 60 or however many that you've got. And just work with a non-layered thing. And leave the layering in your script.
Yeah.
You don't even have to do, see this solid union? That's only there for the 3D printing. I'm probably not going to see the difference between 4 and 7 or 10 millimeters in a photograph of an assignment that I'm literally going to skim over because I have to mark 40 of them just for one assignment. Okay? So, no, but you know what I mean. So, no, because each assignment has like 30 to 40 models. Because let's say there's 19 of you, right? And each of you are submitting 3 assignments for one assignment. I have to mark 19 times 3 assignments just to mark one assignment. So I'm being quick, right? So you don't have to do the solid union for the render. Does that make sense? But you will have to do it for the 3D print. Or, I know I'm going to get a bit of an angry look. You might not even have to do the solid union for the 3D print. You can have separate objects that the machine will just print next to each other, and the way the 3D print works, it'll stick them together, basically. It works. Okay. So
I fixed it though. You can just, like, it was giving me the error saying it was empty, and I just changed the parameters in it.
yeah,
So,
Booleans are fickle. They're fickle, so just be careful with them. Let's not use the Boolean. Let's keep going without it.
So we're gonna
Get rid of the Boolean,
get rid of the
but we are going to still use a Boolean. We have to use this other one called solid intersection. So the reason we're going to use this is if we go massive callback back to our surface, our surface prior to it being untrimmed. Okay, our surface don't plug anything into your solid intersection yet. Prior to our surface being untrimmed, right? We are going to go and grab the boundary curves of our surface. So whichever surface is plugged into your untrim, plug that into a curve component. That's going to give you the boundary of that surface. Okay, we are going to generate an object that's going to intersect our shapes that we're then going to do this intersection, okay? It's more likely to work than the Boolean union that I was trying to get you to do, okay? It's more likely. If that also doesn't work, then you're screwed. And I'm perfectly happy to ignore the fact that you haven't been able to Boolean it. So what we want to do is project that. That's going to project it onto the flat plane. If you've got an object that goes below the world plane, this plane needs to be lower than that. So in that case, you can do that by setting a construct point, plugging that into P, and then changing the Z value of that to something even smaller. So let's say like 100 minus 100. And that'll just project that to a lower plane. That's just a little caveat just in case you've been modeling this lower. Hey Woody, what's up? Okay.
How do I know if that works?
Pardon?
How do I know if that works?
You should be able to see it.
Oh, I can't see.
You can't see the curve.
Number do we change? Sorry.
Z.
Oh. You've got a lovely perforated shell there.
Yeah, but we want to trim
I
it.
can see it. Oh shit, yeah. There we go.
Cool. Okay, now that we've made a projected shape that's flat, we can then use that to create a boundary surface. We could have just flattened the surface, but just thinking about that now, it's probably going to make the Boolean fuck up. No, this is the best way to do it. Cool. We are then going to extrude that surface in the Z vector, and we want that to be a larger number than what our model is. We want it to go beyond. So in this case, my model's about this big, right? So it's definitely not going to be as big as a meter. So if I plug a meter into my Z for the extrude, that's going to make my shape go beyond. And so we've now got a list of solids and a single solid that we can do an intersection with solid intersection. So we can plug our extrusions into the solid intersect with our extruded trim shape. And that should give me the shape trimmed to the original surface boundary.
So hang on, can you bounds right? So.
Did it work? What do you mean? No, don't. Just use it on that one.
On the extrude.
Yeah. Yeah. If you want to use that, do it after.
So I don't need that.
Do it after.
Okay.
And just hide
Everything?
everything except for the outcome, so we can see it.
I shifted points.
Go Control A. Yeah. Yay! So, if you want to add extra panels to that, you're going to have to divide your system up. Yes?
I shifted the points closer to the circle we're working on, but it's still to make it like thin out.
Right, okay. So, guys, it's making it thinner.
Well, I'm trying to make it sort of
Just,
chunky in the middle and thin out.
yeah, so, dude, just remember, see this system here, guys? The domains, these domains here, that domain affects the radius that your attractor point will affect the system, okay? So the domain start is effectively the maximum boundary, and the domain end is the minimum boundary, yeah? Then this thing here effectively controls the gradient at which that zone is being affected, okay? Then the second domain, the one that I've got written 30 and 2, that's determining, okay, this particular point here is going to be 30, and this particular thing here is going to be 2, okay? Or no, actually it's the other way around.
My script's so confused by touch anything that crashes.
Do you have a desktop computer?
No.
Too bad, too sad.
Yep. Okay? Does that make sense? So there is going to be an aspect of this where you have to work out what these values have to be effectively to control the effects of your attractor script. Yeah?
Oh, that's right.
Oh, you've used a random sign
Yeah.
generator.
I don't know why.
That's okay, that's fine. Cool. So if you want this, you can see here under display canvas widgets, there is a widget that would probably be off by default called Profiler. If you turn that on, that'll tell you exactly what's slowing your script down. So we can see here, welcome back, mouse, where are you? If I scroll around, I can see this one's taking 693 milliseconds. This one over here is taking 400. So if you want, you can turn off the things that are effectively slowing your script down to make changes. You might not effectively see the outcomes. We kind of can't.
You go to view.
Pardon?
You go to view.
Display.
Display.
Canvas widgets. Also, turn off the compass. The compass actually slows Grasshopper down, and no one ever uses it.
It's 16 seconds. 16.1 seconds.
Yeah. So
I think I might have a bit too much.
so you can turn that off, right?
Yeah.
You only need that on when you're ready to finish. Yeah. So you can turn now. You could probably also turn the extrude off.
That one?
Yeah.
Oh, 47 seconds, Jesus.
Yeah, but you see what if you turn them off, you can now play and sculpt, and then you can come back and turn them on when you're ready to bake.
I think I've got too much plugged into different things. It's all good. I literally I can't. When you
Yeah, what?
When you copy and paste,
What?
you lose that.
Yeah. So I think
I'm going to try and find it.
I've got some all wrong.
Okay. Why does someone else's hand have to go up?
Because we have the same.
If you have the same problem, what?
Our graph now doesn't work.
Yeah, I don't know where.
What do you mean?
So it's maybe something is wrong at the very base.
Yeah, look, stop touching. Yeah, it's working.
It's working, but you copied you copied this part.
Oh, so that's just to play around with the this extrusion, right? So is this something that you copied?
No, I
You haven't
didn't
copied it yet?
Yeah.
So you can copy this.
So this all is right.
Yeah, it's fine. You can copy this
Yeah.
and use it to control the extrusion. Sorry, that needs to plug into here. So see how that's now, that copied bit is now affecting the thickness? Yeah?
But this one is too large for this shape.
Yes, so you got to see these numbers. These are effectively the numbers that you're controlling to set the thickness. Does that make sense? So then, but look, that's your outcome. So you might want to play around with the size of the panels, because see how this panel is getting trimmed? Yeah. Cool?
But why changing the size of the panel, like, it doesn't work?
It doesn't work.
Doesn't it?
Yeah, that's true.
Because the offset's too strong. So the smaller the panel, so think about it like this, right? If I've got a shape this big and I offset by a number, then it works, right? It offsets to that big. But if I've got a shape that's this big and I offset that same number, it disappears. So you just have to play, if you make them smaller, if you make that number smaller, you can make your panel smaller as well.
Oh, we need it still.
It's not the file that you say about.
I got things.
Okay.
Pardon?
I got things confused since the diamond thing.
It looks like you got a box. Hang on. So what you need to do to get this to then rotate, do the full thing, is if you plug that into a group and then run that rotation, same rotation on that group, it'll rotate it the same way.
So don't do what I've done, just run rotate 3 times.
No, look, you've got a rotation there.
Yeah. That's what I haven't done that.
Where's your rotation from the previous script?
Oh.
There, copy that.
Yes.
Copy it. And go to the end and paste control shift P, D, and then plug. Well, you need to group that first. Plug it into the G, and then preview the outcome. Do you have a mouse?
I do, but not with me.
Sorry, I should have been more specific. Do you have a mouse with you?
Oh, there we go. Brilliant.
Okay.
But the only issue is that it's the point.
Oh, I think I know what's causing the computer to be slow. Guys, sometimes Grasshopper becomes slow because of the way that it's trying to display the geometry on the screen, not actually for the way that it's processing that geometry. So it's taking a while to actually produce the display geometry. And so here, when we have our display geometry set to low quality, sometimes it still takes a long time to produce that. And so what we want for fast quality display is actually the document quality. And if you set document quality for the display, it could actually speed your process up, the script up, purely because it's speeding up the display.
Why solid intersection?
Oh, no, because that's the point it sits on.
Yeah.
So I've got to play around with these.
Yeah, you have to change the.
It comes up with this.
Play around with
error.
Yeah, it broke. So basically, do you remember what I said about the, is that the Boolean intersect?
So I didn't have any problems before that.
Email support material with mouse.
It's gonna cost you a lot of money.
So I just put it on my text and I'll wait now.
No, you can't.
Oh, so does this print? So how, when you bake this, do you have to print the base as well?
And print it off.
You know the 3D printer.
No.
It prints its own base around your object.
Oh, so the fact that that's blank doesn't mean anything.
No, it is. That's gonna fall.
Oh yeah, so that's not going to stay on. That's just going to start the whole thing.
It doesn't.
But what the printer does is like say bring it in.
Yeah.
It'll print the base like that. And then it'll
I got a USB.
Oh, so
Huh?
it's not hollow.
You've got a what?
and then what happens is do something like this. It obviously prints up, so it'll print up support material. So to get that middle bit, it'll put something there,
Right.
and then you can fill it away. Pretty cool. Would you get a chance?
Whoa. Oh, look at this. Oh, it's so nice. So much better. Now, why the fuck is this broken? Oh, it is because I think you're working with the normal surface. Yep. Why have you gone back? Why have you gone back? I remember fixing this when you were more.
So I was trying to connect it so
It's okay. It's okay. No, you don't want to do that. That's gonna cause you strife. That's exactly what it caused. Yeah, like you got your broken bullying interception, right?
So if I deleted all this stuff I copied and pasted,
Yep, then you wouldn't have it.
it would speed up the machine.
Don't delete it, no. Just turn it off. You got one of your offset settings, right? No? Okay. Scripts. Text. You sure?
Yeah. Slowly. Still got that little bit. To be honest, you could probably just print it like that.
So they're all going to support each other anyway.
Yeah, so it'll print that, but it just
Okay,
won't join
so
up.
this number,
So
that's the number you're offsetting by. You're not
Yeah.
offsetting by.
It'll just, yeah, it'll be there, but you can just leave it.
You're not offsetting by.
Yeah, that's true. Yeah.
Oh, that's going to take forever. Oh no, that's quite well. So then just highlight. Do I need to make the surface printed? No. So I can just fake that.
It needs to be a mesh.
Yeah, it should kind of be like a wiring.
So
So you've
if you
still got
select
to-
everything and I remember that, yeah, something like that. Yeah.
Not this Mac, the Mac.
So then just file save that as an SD.
.stl, yeah. And then it'll ask you a couple questions afterwards.
What should you have? What should you have? You wish you knew.
I also
What's going on?
Yeah, so that's 0.0.
Yeah.
Yeah, that's fine.
Untrimmed device sections.
It'll ask you another question.
Got 144.
Just calculate a lot of points.
No valves. Piece of shit.
Oh, binary or ASCII.
Yeah, but
Okay.
well,
Approximate size, that's a lot to try and.
yeah.
That's right.
Yeah. It's broken that whole thing down into bits.
Oh, really? So then what was the program? Oh, you wanted to, sorry, I'll send it. Well, the only thing is you have to lower that onto the base.
Oh,
I'll have to lower that onto the base.
Yeah, so when you put it into flash, it can actually.
So basically, if you want to print it like that, it'll just draw out
So then when I look at this,
plastic.
I
Also stuff the whole room. So when you go to print it,
so then you turn this into.
you actually have like a base on the program, so you just grab the whole shape.
Make it.
Right.
Group it, rotate it.
But yeah.
Make it. Print it.
So I just want that straight from
Have you done the induction of 3D printing?
no.
Did I just group? Why not?
Because I've been away.
Yeah, but you should have done it like at the beginning of the semester. Okay, so you've got until next week to 3D print this. You've also got until next week to be inducted. So you've got to be inducted soon, right? Now, how do you get inducted?
Friday morning.
Friday morning. That's it. Okay.
Friday morning, 10 o'clock.
Awesome. Okay. Yes. You need a booking.
Yeah. So you need to go onto the website and you need to.
If you can make sense of it, you'll get what I can.
Cheers. I'll see you next week.
So, what was so it's that, so it's like rotate, and then degrees, yeah, you should have a rotate basically copy and paste that. Copy and paste that.
And I'll get rid of that. Just select it.
So it's my last fix.
Yeah, that's what I do. This is too much. There's just so much in this project. I'm like, if there's issues, that's fine.
Oh yeah, so sorry, what was the program you said? Gives you time?
Slash print. It's the same program you have to plug in when you get to the.
Okay, and it's free to download?
Yeah, you can just get on your computer, you can do it at home. But you can also go down to the lab and plug in and see the time.
It's still. So.
That looks like.
Just when you look at the planet. What do you know about it?
Maybe connect.
What do we know about it? Not much, right? What is the sequence? That's the section code. Okay, what's the O input? What's the O input? Okay, so what do you plug into the options? What's getting plugged into the options?
Wind.
You were saying in the lock options. It's like when I say what's your favorite color, you say lemon. Oh, that's a color. When I say how old are you, and you say lemon, that's what you've done. Pardon?
Did you find it?
Yeah, it's downloading now.
Yeah.
So it's worked out how long it's
Yeah, well, you'll have to save it, so you have to support material through it and you basically run it as if you're going to print it.
Okay, so
Yeah. Yeah, if you open it up now.
How long does it usually take to print 150 by
150 by
You don't
150?
need this because this is your full object, right? You
I don't know, I'd expect about 10 hours at least.
10 hours?
Yeah. Yeah. Because it's got a lot of supports,
Okay.
it's going to have a lot of supports in there.
Thanks, mate. And the USB thing?
Oh, which format then will we save?
STL.
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 Oh,
Yeah,
STL.
Use that. So you don't have the previous screen yet. So just leave it out. So then it's working.
Yeah, so the machine type, you'll have to
Okay,
set it up.
changing distance? Yeah, so you know the control points that we're using to do the
Depends
attraction?
on how big you want it.
These points. Yeah, these points.
Yeah. So it's green. You can go machine type. And so we already supplied it to all the finders. The finders is this
Yeah.
So you can go cut here, and then you set to go cut by the
So we just need to.
the slice up and then
So I want to make small sections.
yeah, just so the find a bed is 150 by 150. So you can make it 150. So that's up to you.
Oh, that'll be a production.
Yeah, that was like 20 minutes.
Yeah.
But if you have any support material.
Okay. So this is going to take a lot longer than
Yeah.
that.
You have to wait. You have to wait.
Oh, it's still
She's
preparing.
So see these guys are getting too small.
So can you print overnight?
Yeah.
So that's 7.
Yeah, you just have to book up until 5. You have to have it booked until 5 o'clock.
These
Then
are
we
just
start
starting.
5 o'clock. If you have your booking running right up to 5 o'clock, you need it.
And these
So
numbers
then,
are going to control the extent that.
So I won't be able to have that till Thursday.
So
I'll
just
say
it's-
all.
Yeah, we put it on the shelf. Yeah, you just kind of like it. Yeah, if you click on I can help you with it. It'll be easier on the desktop because we've got there than on the laptop. So yeah, that's fine. And I mean, I don't know how much it is, but there should be.
Yeah.
The reason.
So how do you book
You have
On the
control.
beacon making website.
like maximum weekly hour is 1 hour?
No, that's just for laser cutting. Yeah, 3D printing is on.
Yeah.
So can you just book 4 to 5 and in
Yeah.
overnight?
Yeah.
So we just have to pay 1 hour. Or
No, you have to pay for however many hours your print goes for. So it's $4 every hour it goes for.
Sorry, yeah.
We got it. This is proving quite an expensive course. Thursday.
So how did it go for me?
Yeah.
But I'll see it, I'll probably see it before you see it.
Yeah, true. Oh, yes.
Yeah, you can come
Thanks,
back.
but for.
You obviously do graphs,
Yeah.
but.
The diver is a big one, and the finder is small.
Okay,
You're
so
gonna
I'm
get
gonna
smaller,
use
and
scales.
you're gonna find that, yeah, you're likely to get. We've only got 3 of the dives, so like if everyone wants them, then they can look at it. If you don't want to find it, then you'll get it printed much easier.
What do I do for rent? Just slide? Sorry,
Yeah, and the password, depending on what's the password.
Just do, like, if you want to submit
So you'll have to
the
do it
crazy
just 4 to
shape
5.
in the document.
Yeah, and then the password is
Then
designed for you as well.
just 3D
All
print simple one.
lowercase.
Oh, yes.
2018.
Who am I looking for? Hey, who? Hey you. I remember Hey you. Hey you's in the end. They're not ordered by Mark. So yeah, don't worry about that. Don't read into that. Maybe Hey you is not at the end. Should we on? Good. Yeah, you are an idiot. You're welcome. So basically, these are a decimal. What do you mean?
No, I just put the right email in.
No, well, that's good.
Are you doing it
That will
round?
show up
You
on my
want it rounded?
system.
I will, okay.
Yeah, yeah.
Alright.
You might,
It's
I don't
rounded
know
up, but
if
it
you get
goes
the
to,
email, but that says,
okay,
yeah, it'll
cool.
work.
Alright, perfect.
So it should be on the computer.
So it's basically.
Yeah. I'll do that.
it's more so with the hinge, the alternating pattern. You didn't have the alternating pattern.
I'm going to see if I can see that.
But you know, you're doing well. These marks are all going to get homogenized there. So a lot of you are probably getting like an average, a much stronger average. Like if I go, okay, here's like a whole bunch of points. The average through there is like that, right? So at the moment, that's a like, you know what that number equates to? So it's good. Okay? But so what I'm going to do at the end is basically push people up. So your mark's going to go, everyone's mark's going to get higher at the end. Cool? Yeah. Yeah. The way this, I don't know how Christina's marking, but the way I've been marking, I'm starting to see a really strong like average, and there isn't really much extremes. So I'm gonna just at the end scale everyone up, not out. Yeah. So I'm gonna take the bell curve, and I'm gonna do this. I'm not gonna do this. Cool. Yeah. Yep. Yeah, it's not fair. It's not fair on people if you're passing them and suddenly they're failing because you've rescaled. I'll be there in a sec. Hang on, let me just stop recording so what I say doesn't get me in a whole bunch of shit.